a visual, I'm guessing, some sort of visual cue or some sort of visual calibration card. Oh no, those are their sponsors. That is awesome. Big hand for the sponsors of the North Dakota robot right there. That's multitasking because he's got to hold that up while he's also working on the robot. Yeah, buddy. That's actually the side plate for the robot. Now they're installing it. Now, how inventive was that? So, North Dakota on the left hand of your screen and the University of Alabama on the right hand of your screen. Both of these robots, very similar in design. Both of these robots have a rotating bucket ladder, a bucket ladder system on a series of belts in order to excavate down deep. And then they both have conveyor belts to offload the collected materials.
So Kirk, I had to come up here for a second and give the University of Alabama a hard time because this is Gator country down here. And this SEC, I know, but I know y'all want to roll tide, but this is the SEC country and this is Gator country. You guys do well every year, but I just want to give y'all a hard time. So,
look at his Gator hat. Have you seen that?
That's pretty neat. That is. Let me borrow that thing for a second.
It moves.
Come on stage. What's your name?
Matthew.
Are you a Gator fan?
Not really.
Where'd you get the Gator hat from?
We just had it laying around our lab, and we took a liking to it because, let's face it, it's absolutely adorable.
What university?
Say again?
What university?
Alabama.
Can you give me a roll tide?
Roll Tide!
Good luck. Thanks a lot.
We had a gator not much larger than that one walk through here yesterday. It walked right over there and went all the way back to the pond back there. It was so adorable, man. It was about that long. Teeny tiny little teeth.
Is it a gator or a lizard?
It was a gator.
It was a gator?
It was a gator.
Okay.
Josh over there basically escorted all the way over to the lake to make sure it ended up safe and sound in the lake.
If I saw that gator, I would have needed an escort to my car because I would not have been able to do this today.
That gator was so tiny, it could only take your pinky off, I think. Worst case. It's all relative, you know. I still wouldn't want to pet it, obviously.
No, absolutely not.
Unless its mouth was taped shut like they do at the Gator Farm. All right, these two teams have 30 seconds left in their setup time, but they are exiting the arena, so I think both teams are ready to go. Alabama obviously has autonomy. Let me check my notes for North Dakota.
So assume both of these schools are veterans to the competition, so we should expect to see a lot of action from both of their robots that we see on their second run. So I'm pretty excited to see this run get started here. It looks like they're on their way.
Yeah, second run for both of these teams. Both of these teams are veterans of this competition. They have both been here every single year, all 9 years. Of course, when I say that, the disclaimer is that students rotate in and out every year. So sometimes you end up with a whole new team based on people leaving. But both of these teams, robots, they look like they're very similarly designed, similar power, similar size. So it's going to be great to see these two run side by side, especially since they're both super veterans, and this is their second attempt for both of these teams. They're just going to go for it because this is their second attempt. Usually the teams start out more conservative on their first attempt and then take more chances on their second attempt. The Alabama robot, not concerned about obstacles, it looks like, just drove right through the obstacle field.
So one thing about this competition that I really like, and I think it's interesting that we do, is when the teams start out, they actually spin a little board that tells what direction their robot faces and where their robot is placed inside of the arena. So it's all done on random luck of the draw. So sometimes the robot is facing the right way that it needs to go forward to get to where the regolith is, or it's facing to the side and need to spin around. So I always think that's interesting how we do that.
That's true. We got to throw in a little bit of a curb, throw in a wrench, because we don't want to make it too easy. We want the teams to be able to handle real life situations and be flexible, and so that's why that rule was implemented. Now the Alabama robot is running autonomously. You can see when it binds, when it gets kind of stuck, it backs up, lifts up just a hair, and then starts again. That's part of their autonomous system, their autonomous software that they've added this year. And both of these robots are digging quite well. North Dakota on the left, Alabama on the right. 8.5 minutes remain. So North Dakota, in that shot right there, you could see their conveyor belt was spinning. And I'm presuming that they're just dumping out the initial material that they've dug because they don't care about the initial material. Both of these teams need to get all the way down to about a foot, about 12 inches below the topsoil before they will get to the rocks and gravel that we have buried under there for them to get. They don't get any points. They don't get any score at all for the loose topsoil. They only get points, scoring points, when they collect the rocks and the gravel that we've buried. Here comes Alabama.
And it looks like they both have this similar design using the bucket system, North Dakota and Alabama. I think it's going to come down to operator and the implementation of the design strategy, Kirk.
Yep, Alabama is depositing their current load onto the hopper, and now the judges are going to come along and they're going to sieve it, they're going to filter it, and see if there's any gravel or rocks in there, because only the rocks are going to be scoring for these teams. Now, the Alabama robot, if it really is in autonomous mode, let's see if it goes back to the exact same hole or if it picks a different hole. I think last year it picked a different hole, but in this year's competition, in this year's rules, it would be better to dig down in the same hole over and over and over, which is exactly what it is doing. So it would be interesting to find out if how this robot is remembering where to dig. Is it just keeping track of wheel turns, or is it using some sort of sensor in order to find that hole and dig in that same hole? Look how deep this North Dakota robot is digging. And you can see when it binds up, because this material is not easy to dig in. It can resist your digging forces and make your digging mechanism stall out.
So, Kirk, we've been doing this robotic mining competition for several years now, and I know you've been a staunch member of it and a big supporter of it. Give me, in your opinion, why is it so important? Why is it so important to NASA, and why is it so important to you? Can you talk to me a little bit about that?
Sure. This competition is important to NASA because it advances, it moves forward these technologies, how do you drive on this crushed volcanic rock? How do you dig in this crushed volcanic rock? How do you find and collect the icy regolith, the chunks of ice that are buried beneath the surface? What ways work, what ways don't? Because NASA's going to need these technologies and these tools in the future to send robots to the moon and Mars that are autonomously or remotely controlled, that are performing these roles, that are performing these functions. And digging down and collecting the frozen water, the ice chunks that are under the surface on the moon and Mars, because we'll be able to use that ice and turn that into useful resources someday that will support a human colony or support human explorers.
So I understand the benefit that NASA is receiving as an organization. Can you share with me what some of the benefits might be from a student's perspective that is participating in this competition?
Yeah, the students gain a lot of benefits from this competition. You know, besides bragging rights of, you know, saying to their friends and family that they competed in a NASA robotic competition. I mean, that alone is pretty cool. But these students are gaining all this experience of completing the entire systems engineering life cycle. They're coming up with a robotic design. They're writing it down on paper and showing it to people and getting feedback and having it reviewed. They're buying the parts or making the parts for these robots in some cases, and then putting them together, and then troubleshooting all the issues along the way and doing all the testing along the way of the subsystems, and then putting subsystems together and testing systems of systems. And so when these students put that on their resume when they graduate, they have a huge benefit over other students that haven't gone through a competition like this. So regardless of how these students end up scoring in this competition, they're all winners because they've got this great experience to take them into the next phase of their life, into the workforce.
Would you say that a competition like this gives these students practical experience in how we operate as an organization here at NASA, when you have to collaborate as a team to come up with the design and to complete various taskings or missions that are assigned to you? Would you say that's real-world experience for them?
That's exactly right. This competition is designed specifically to give the students experience in the same kind of work that the NASA engineers perform on a daily basis. And so that kind of experience is just second to none. There's just no other, there's just nothing else can give you that experience, in my opinion.
Kirk, check out this this shot here. It looks like that's from South Dakota. Is that South Dakota?
North Dakota on the left.
From their machine there.
Now they started another hole right there, I'm pretty sure.
And it looks like Alabama's dug a trench over there.
Alabama's digger was very, very deep right then. They have gone to the same hole 3 times now, unless I've lost count. And North Dakota has started a second hole, I believe, in a slightly different spot. Both of these teams have 2 minutes left in this run.
So far, it's been I'm very impressed by both of these teams' robots. From the size of their holes and just the overall activity that we've seen on this run, I'm quite impressed.
Yeah, both of these teams are performing really well. There's a shot on the left of the pile, the onboard material on board the North Dakota robot. Now, with 1.5 minutes left, is the North Dakota robot going to have time? You know, it slowed it down pretty heavily. I don't know if it's going to be able to traverse as quickly on the way back as it did to get there. You can see the North Dakota digger coming up out of that hole. Now the Alabama robot, I know they have time. That's a very fast robot. It goes over the same exact path over and over and over. It never diverts from that path. So there's no reason why this Alabama robot can't deposit one more load towards the end of this run. And here comes North Dakota. Let's watch as North Dakota lines up with the hopper. And then here comes Alabama on the right. So the Alabama robot has a couple targets, some visual targets that they've installed on the hopper that the robot uses to align itself. And
Kurt,
there it goes, 30 seconds remaining.
Can you talk a little bit about, as the run is about to conclude here, what happens to these robots once they complete the run? Can you explain to me that process? So what the teams do once the run is completed, where do the robots go?
Look at that. North Dakota just dumped an amazing amount, and they're still dumping. So with 10 seconds left, after these robots compete in this 10-minute competition, right there, we've just finished. Both of these teams, these students are going to come back into the arena, and they're going to pick up their robots and pull them out of there. And we have this process right outside the arena where they're going to get vacuumed off to make sure that none of this dust gets taken back into the robot pits. I want to give both the University of North Dakota and the University of Alabama a big hand for that run. That was an amazing run for both of those teams. And we will find out later when the official scores are posted how many rocks, how many kilograms of rocks and gravel those teams were able to deposit into our hopper, which simulates the lander that these robots were dropped off from. Now here come the students into the arena to take their robot away back to the robo pits. Now if you want to check out these robots in the robo pits, you're welcome to do that. They're open to the public. They are in the gray building over my right shoulder. It says Center for Space Education on the side of the building. That building is open to the public all week long, all day long, all week long. And you're welcome to walk through that building and look at these robots close up in the pits and talk to the students. The students would love to tell you about their robots. They'd love to talk about their design and how they've come up with these robot designs and what the innovations were that they have come up with for their robots. So make sure you do that. Another thing that you can check out while you are here this week experiencing the visitors complex and experiencing the NASA robotic mining competition is you can go check out some of these robots operating and testing in the sandbox, which is an area right outside the IMAX building and right outside the gift shop. There's a pretty good sized sandbox that we've set up for these teams to practice in and to demonstrate their robots to the Space Center visitors. So check that out. I believe we also have some high school FIRST robotics teams that are showing off their robots in that same area. This is the 9th annual NASA robotic mining competition, and we are streaming live from the Kennedy Space Center Visitor Complex in Central Florida. Now, coming up next, we have the University of Arkansas and Embry-Riddle Aeronautical University. So you don't want to go anywhere because you'll miss Arkansas and Embry-Riddle coming up next for their runs. I know the folks online are anxious to see a schedule. I'll give you a heads up for who's queuing up next. After Arkansas and Embry-Riddle run next, we have New York University and the University of Minnesota Twin Cities in the queue after that. So don't go anywhere. Now Derek has one of the Alabama students. Let's see what they have to say.
So I'm joined here by Max from the University of Alabama. They just completed their second run. Max, how do you think things went?
Things went all right. The system performed roughly as we expected, but not quite as well as we wanted it to. The last number I saw for kilograms was 0.8, which they might round up. But the system was fully autonomous as we expected, and we got the 3 dig dump cycles like we wanted to.
So what adjustments did your team make from its first run to the one we just saw a few minutes ago?
In our first run, we ended up dumping a lot of material right at the offloading bin, but it just barely missed, so we shortened up some hard stops so that we can more efficiently offload, and then we changed some of our autonomous algorithms because last run we saw the whole system just stop for 10 seconds, so we tried to eliminate that issue.
Okay, does your robot have a name?
Yes, the robot's name is Little Owl, after our university's mascot, Big Al.
Is that the elephant that I see on TV all the time?
Yes, sir, that would be him.
All right. So my final question for you is, how are you feeling after completing the run? Are you happy? You satisfied? Or what are your thoughts?
I'm a little nervous at whether or not we actually qualified, so not too sure how things are going to go yet.
Well, I appreciate you taking the time to talk to me today. Let's give them a big round of applause for the University of Alabama.